Kia ora, and welcome to this quick overview of the PhET simulation. Now, you've got 2 atoms, 3 atoms, or real molecules, but the real molecules is not available in this HTML version. You have to use the Java version. So let's start with the 2 molecules. Notice that if atom A and atom B have got different electronegativities, I have a separation of charge called a bond dipole, and I can show it by clicking on partial charges. You can see this is a bit more positive and that's a bit more negative. And I can show the bond character, which is somewhere between covalent and ionic, and it's called polar covalent. If I make the electronegativity the same, then I have a purely covalent bond, and notice I have no bond dipole. And if I move this around, it doesn't make any difference because I only have 2 atoms. If I increase the polarity, and especially if I click on this so you can see the color change, then notice how the bond dipole is always from the less electronegative to the more electronegative atom. And as I increase the electronegativity of B, this side becomes more negative and that side becomes more positive. So play around with what happens with the electric field on and any of those buttons. Then try the 3 atoms. Now with the 3 atoms, you can move this around. So if I make these equal and opposite each other, notice what happens to the molecular dipole. It disappears. And that's because if I look at my bond dipoles, they are equal and opposite to each other. They are both going in, and because they're opposite, going in opposite directions, the bond dipoles will cancel each other out. And so I don't have a molecular dipole. If, however, I change the angle of C to B and A, ABC, then these are not opposite each other anymore, so the bond dipoles can't cancel out. So C is pushing electron density into B, and so is A, giving me a resultant push or resultant electron density in that area. So if I show my partial charges, this is the slightly negative atom, and this is these are the slightly positive ones. And if I can move it like that, you'll notice I have a much bigger molecular dipole. So play around with that. What happens also when you have, say, atom C being most electronegative, then you can see how there's a polarity bond, polar bond here as well as over there, and they're adding up, resulting in a much bigger molecular dipole. So explore what happens in terms of both shape, and to see how if the bond dipoles cancel out, or if they have got different electronegativities, and see what happens to the bond dipoles. So the important things here are electronegativity, bond dipoles, and then the overall resultant molecular dipole, depending on the bond dipoles and the shape of the molecule. So have fun exploring. Good.